Hi, we are Jongho and Hyunjang in Computer Science Department. Today we are going to talk about our project, Performance Improvement of LSM tree-based storage engine.
What we chose for LSM tree-based storage engine is RocksDB, which was developed by Facebook. It is widely used in many services like Pinterest, LinkedIn, Airbnb, Uber, and even Netflix. The problem that we focused on is the longer the transaction's lifetime is, the more read amplification problem we get. This problem was pointed out by our seniors last year project.
To find out the solution, we analyzed the operation flow using GDB, perf, and callgrind. Let's see the original implementation of RocksDB. We break down the whole flow into three parts. First, get SSD file in level order until visible snapshot is found. Within a single SSD file, we must traverse Bloom filter, index block iteration, and then Bloom filter again, finally single block iteration. If the key is found, here comes the sequence number only for visibility check. Since the validation of sequence number is done at the end of each find, the failure of this validation will cause extra loop to find the visible snapshot. Therefore, if read transaction's lifetime gets longer, it could be the bottleneck.
To handle this bottleneck, we implemented the new feature sequence filter. It is an in-memory mapping table of user key and sequence number, and it stores minimum sequence number for each key. When SSD file is newly opened, SSD file table reader is created with sequence filter. Sequence filter stores the user key and the sequence number in hash table while traversing the whole SSD file. So, where should we put this sequence filter? Right after the first Bloom filter. By doing so, we can check whether the key exists or not. If the key exists, check if the minimum sequence number is visible to the transaction. If the key does not exist or the minimum sequence number is not visible, skip the file traversing. So, for this example, red will traverse file, but green and yellow will skip the file because green's key does not exist and yellow's key is not visible to transaction.
This is our experiment environment. For hardware, we use Intel Xeon 256GB RAM, 1TB SSD storage. And you can see other detailed RocksDB setting in this slide. Let's see how effective our sequence filter is. We used two types of work lots. One is uniform and the other is skewed. In both of those work lots, we can see the performance gain in read transaction. Especially in uniform case, the performance is tripled, and in skewed case is doubled. Also, we could notice that there are less file traversing when using sequence filter.
It was a simple idea, but turned out to be effective. Our current sequence filter is an in-memory structure, requiring the whole file scanning for a newly created SSD file. So, for the future work, we will suggest the persistent storing method for sequence filter to reduce that whole scanning overhead. Thank you for listening.